I'm sure. Thank you everyone for having me here today. I'm an astronomer. I don't really know much about biosciences or pharmacy or anything. And this is actually a talk that I gave, an invited talk at Tucson in Arizona that I was in at November time. And already the stuff that I'm like presenting is a little bit out of date because of how fast this area of research is developing. But I'll jump right into it. The essence of the talk is that we're always like wanting more and more like astronomers to come and come work with us essentially. But I wanted people to have a think about what really is an astronomer, what makes them what they are, what the research they do, I guess. But actually this applies not only to astronomers, actually what I have to say, it applies to scientists in general. And I myself came up with like 3 main categories of really what we do. Like I said, it applies to all scientists, so most of you here. The first component is research and analysis. So we try and formulate ideas to research, new problems to tackle. A lot of my job is actually coding and then debugging code and then doing the science, which is essentially analyzing the data and analyzing the results and trying to interpret that to kind of solve the problems that we were looking to solve. The second component is documentation and publication. So this is reading and writing proposals, reading and writing papers, publishing papers, writing grants maybe, all that kind of stuff. And then lastly, communication and dissemination. So we get paid by the taxpayers to do the research. It's kind of really important that we kind of give back to the community, present our research to the general public, as well as presenting at conferences and other things, lecturing at university, for example, as well. This talk is largely surrounding the concept of ChatGPT. Can I have a raise of hand who's heard of ChatGPT before in this room? Okay, so everyone, that's really good. How many of you have heard of ChatGPT 4? Okay, some of you. And how many of you pay for ChatGPT 4? None of you. One, okay. So ChatGPT is a large language model. It's a machine learning algorithm. Essentially, you kind of put in some text, it encodes it into some kind of encoded space, pushes it through the model, and you get some decoded text back, essentially. And this is trained on essentially the entire internet. I would say that those of you who haven't played with ChatGPT 4, you should really try it, see how it goes for a month. It's about $20 a month to get. The differences between the two is actually really big. Especially you'll see from some of the stuff here. But ChatGPT isn't the only large language model. Here's a big tree of like the evolution of large language models and the different approaches that they've taken through the years. Some notable ones are like Google Bard, which I equally use as much as I do ChatGPT, because we know that these models are generative, they're making things up. So it's not always that they're going to be factually correct, although ChatGPT is probably the most factually correct of all of them. They use human reinforcement learning to feedback to help improve their algorithms. They use adversarial testing to really try and break their models, to make them wrong, to improve them from that. But there are other models that are free, like Bard, Llama, Bing chat. Bard and Bing, at the time of writing, those two had access to like live information and internet searches, whereas GPT didn't, and I think GPT 3.5 doesn't still. But 4 now does have access to the internet. Anthropic Claude is a bit nicer to work with, a bit more friendly. It's got larger tokens, so it can take larger chunks of text. And then you've got like Chinese versions like Baidu, etc. Some are open source, some are not. If you go to the Hugging Face large language model leaderboard, actually like ChatGPT isn't even like close to the top anymore. There's so many like differences in these models that people are able to improve them specifically to do the tasks of whatever they're testing for on this leader model. So these are like how factually correct they are, how creative they are, etc. There's loads of like different metrics they're looking at. Okay, so for science, I wanted to know whether or not ChatGPT can replace astronomers or scientists in general. So one of the things that we do in astronomy is classify stars. So I went to Kaggle. Kaggle is a great place to get data sets. It's a competition website. Quite often companies and other people will host competitions on there for people to tackle problems with their data. And I fished out this particular data set, Sloan Digital Skies Survey. And essentially it's like a tabulated data set of 100,000 observations. And it contains things like stars, galaxies, and AGN or quasars, which are essentially bright black holes. And in these observations, they've extracted 17 different features. Okay. So the first thing that I asked ChatGPT to do was I had this data set, I uploaded it, and you can literally just add it as an attachment to GPT-4. And I asked them to describe the data. And straight away, it went ahead and did this. It was able to get all of the column names and what they meant. I didn't tell GPT what these columns were, but it was able to say, oh, these are the positions, these are the brightness of the objects in different filters, UGRIZ, the redshifts, so how far away these objects are, and I didn't tell it any of that. It did some basic data processing, so it found no missing values in my data set, it knew the distribution of what was in there, and it was able to do some basic statistics like finding the mean and the quartiles. And what's really great is that you can ask it to show how it got to where it was. So there it was showing you the Python code that it was used to extract this data and present all this information to you. It's imported the correct libraries without you having to do anything. The next thing I asked it is, can you make some basic plots of this data? And it's picked out the important features. So there were 17 features, but not all of them are important. Some of them are like the time of the observation, etc. But it's been able to pick out the actual properties of these objects, like their brightnesses and their distances, which is redshift, and made the appropriate plots. We're going to have a look at this closer in a second. But again, you can ask it to show you all the codes. It's given everything, including the titles of the plots, the correct labels of axes, and it's even done a little bit of a description of what it can see in these plots. And then lastly, I ask it, using the spectral data, build a classifier to identify these galaxies. This is typically the job of an astronomer, right? And straight away, it's talking me through what I need to do to get this done, including data processing, normalizing the features. It comes up with some ideas on how to do this classifier. It suggested a machine learning algorithm called random forest. It knows that machine learning, you have to have training and testing data, and it's correctly like
split this data in half, essentially, well not half, but 80-20%, and it's gone ahead and done this work. It's run the machine learning algorithm, got some results, and even made some basic metrics of what the behavior of the model that we've trained, essentially. So these are like precision, recall, F1 score, all the things that you would typically want to analyze if you were looking at a machine learning model of this. And then lastly, I said astronomers have to interpret the results. So I ask it, what are we learning from these results? And it's come up with some really like good interpretations. It's being able to fish out like what objects are misclassified as other objects. It's being able to give us some ideas on what features are the most important. So it says like redshift is quite important, etc. It tells you a bit about the model that we use and how it compares to other methods, how you can improve it. Basically everything that you need to think of as a scientist, it's basically done for you. Okay, so let's have a look at these plots more closely. So this is the U-band magnitude, which is basically the U-band, the brightness of the object in the U filter. This is a continuous value, so it's correctly put it as like a continuous distribution. The other feature, class, is a discrete variable. It's decided to put that as a histogram. I never had to tell it specifically what type of plot to represent these features as, and it just went ahead and did this. Without me telling it what to plot or how to plot it, it knows it straight away. Again, for redshift, a continuous variable, it's made this distribution plot. When you're plotting the brightness again against redshift, two variables, it's correctly used a scatter plot. It's put in the correct like titles, legends, etc. And then these are like some of the main results that it came up with. Common misclassification of galaxies with quasars, feature importance in order of the importance. They said redshift was most important, and then Z magnitude, G, U, I, R magnitude in order, and then some improvements like feature engineering, data augmentation, and hyperparameter tuning. Okay, so that's like the first bullet point that I said. The second bullet point of an astronomer I said was reading and writing and publishing results, right? So I don't think I need to convince you that ChatGPT is great at writing, but one thing that you can use ChatGPT for is literature reviews. So you can ask it to use plugins like Scholar AI to find articles that are related to star classification or use that particular data set. And away it goes and processes this. It's found this paper, experimental analysis of stellar classification using different machine learning algorithms. It's come up with an abstract, which is not the same abstract as the actual paper, but it's summarized it itself. And you've got the link there. So all of these things are actual publications, and you have the link to them to find them, which I think is really great. It can really accelerate the time. If you don't have time to do a full literature review, just ask ChatGPT, like, what papers do I need to look through? Because sometimes it can be really overwhelming, right? And then you can also ask it for more details, more papers if you want to. All of these work. And coming to the third point, disseminating these results. These are the kind of things that I came up with. You could use ChatGPT to come up with an outline for your presentation. You could ask ChatGPT to visualize your ideas. All of the images that I've used in this presentation have been created by ChatGPT. So it does have an image generator in it. It uses DALL-E. You can use ChatGPT to get more concise definitions and explanations of terms. And you can use it for preparing for your Q&A session after your presentation. You can say, this is what my talk is about. What kind of things will people ask me about? And it can help you prepare for that, which I think is really great. Actually, another thing, this entire slide was actually made by ChatGPT. Like, not just the content. I asked ChatGPT to come up with VBA code to make this presentation. And it came up with Visual Basic Code. You literally copy and paste it into the macros of PowerPoint, and it comes up with this slide, which is insane, in my opinion, including all the animations. But there are some things to be aware of. Should we use ChatGPT all the time? Why don't we just use a search engine? And I guess the answer isn't always so simple. Actually, if you take a look at the energy consumptions of the two, a Google search takes about 0.3 millijoules of energy per search, per query, but ChatGPT 4 takes 30 times as much in general. So it is like not so climate friendly. Should we really be using or relying on ChatGPT or large language models all the time if we know how unenvironmentally friendly they are, especially for training them? Like, some models that you train and optimize are like much more like polluting than like several cars running for like a year. So that's something to be aware of. The other thing is you have to be careful about what you say and how you say it. So I asked ChatGPT to come up with an invite to Elon Musk to come to the conference that I was presenting at. And one of these statements was from ChatGPT, and the other was something that I made up myself. So, hey Elon, we know you love space and AI, so we'd love you to come to our conference. Dr. Maggie Liu is talking about AI and astronomy. Or, dear Elon Musk, we would be honoured if you'd grace our upcoming conference with your esteemed presence and share your insights with our audience. Who thinks the left-hand side was written by ChatGPT? Who thinks? My left. This side. Okay. And then who thinks this one was written by ChatGPT? Interesting. Okay, so the answer was actually this one was written by ChatGPT. This one was written by me. I didn't give ChatGPT the context that I was presenting. I just asked them to come up with the invitation. But you can make it more precise. And the idea is prompt engineering says that if you're putting trash into your model, you're going to get trash out. So this is going to change the way people write, right? Because in the past, well, in the near past, right, people like to write in slang and are not very clear about stuff. But if you're chatting with ChatGPT, the more information you give it, the more precise and clear words that you give it, the better it will be able to adapt its content for you. And that's going to change how people write, because we're going to get a new generation of people who are amazing at writing, and they're going to excel at dealing with this. Okay. The other thing that we should be aware of is that even though the number of AI papers are increasing, this is in astronomy over the years, you can see that the number of refereed papers are not, the ones that are accepted, etc. So the quality of these papers are not increasing. And the example that I showed earlier about stellar classification, that was such an easy task, right? And we're seeing a lot of papers like this. I'm an editor for a journal, and a lot of the papers that I'm seeing are doing exactly the same thing, like maybe with a different data set, and not improving on their methods or results. They're just doing the same thing, I've just got a different data set. And so maybe you are producing things, but you're not producing high quality things using AI. So an example of this is one of the models that I'm working on is called a variational autoencoder combined with a spatial transformer network. The idea is that we're trying to shrink these images of, well, in this case, galaxies, but in my case, galaxy clusters, into some latent space and extract the information, this latent space parameters of what consists of these astronomical objects. This kind of stuff ChatGPT is not really good at because it's novel. There's not many examples for it to learn from. This kind of method is great for extracting like overlaying objects. So for example, if you had like an image of 6 and a 7 overlaid with each other, you could literally pull them apart because the latent space tells you that one of them is a 6 and one of them is a 7. We've done some practice stuff playing with like overlaying clothes on top of each other. It would be great for like removing glasses from people's faces for facial recognition. That's Stephen in physics, his a paper that we're working on together. But I'm applying it to clusters of galaxies, trying to disentangle merging clusters of galaxies, and you can see the residuals down here. This is not something that ChatGPT has been very helpful on. It's also worth mentioning, so these are like kind of the latent parameters that I'm extracting out. So with 3 latent parameters, you can find like clusters are merging, you've got a central halo and some extended halo to characterize their masses. It's also worth mentioning some of the research that I'm doing with Viren. Last year we had 3 students in physics, Dongzhang, Qi Kao and Ruxing Ming. And we were looking at these worms essentially, trying to model them with machine learning. We made some great simulations from them. We were trying to predict like their growth, how wide, how long they were growing. Using machine learning to do this, because there's just so many of them, we can extract things like their positions and how they move. And going forward with this, we're going to try and go into the lab in physics. We've got this superconducting magnet, 18 Tesla, so much more powerful than your MRI machines, and study like the effects of microgravity on these C. elegans worms to see in different microgravity conditions simulated how they grow and evolve, but monitoring and tracking them with AI. So that actually features as one of the challenges I'll find with these kind of LLM methods. They're just things to be aware of, really. These LLMs, they lack novelty in training data, so they're usually limited, trained up to a certain point. ChatGPT 4 was trained up until, in November, when I originally gave this talk, it was trained up till like July that year, so anything past that point, it didn't know anything about. So you need to be aware of how much information it actually has access to. It's not conscious, so any of its ideas that it's generating are not new ideas, they're just recombinations of other people's ideas, really. It has no experimental capability, so it won't be able to go into our labs and stick our worms into like our giant magnet and monitor them for us. It will be able to help us figure out these things and give us ideas if we tell it, but it can't physically do experiments. It doesn't have a deep understanding of anything, and as scientists, you know, to come up with novel ideas and problems, we need to have a deep understanding of like the field that we're working in and other areas. Everything is limited to the context that you give it. So if you haven't told it something, it won't know that it needs to take that into context. It's also really hard to interpret these things. It's hard to know if it's biased or not in any way. And its creativity is bound by probability. So everything that it's showing you is what's most likely that you want to hear. is what it's going to give you. And I'll tell you why this is a problem. Because right now, ChatGPT is trained on the entire internet, pretty much. And all of that content on the internet is produced by us humans, right? So you've got this broad distribution, some really crazy stuff, right, at the tails of this distribution. But over time, we're more and more relying on LLM models to produce things. Loads of journalists already are creating articles using only ChatGPT. Lots of coders are just relying on ChatGPT to make their own code. And as time evolves, these large language models are only going to be training on the data that it spat out itself like 1 year ago, 2 years ago. Eventually, you get this distribution shrinking and you'll get mode collapse. So it's unclear how this will affect future generations of LLMs if it's only training on the same content over and over again. That's a scary thing, I think. But don't worry. I like to use this analogy with the AI stuff. Right now, like, we have huge factories that are able to produce cakes very cheaply, mass manufactured, beautiful cakes, right? But we still have these beautiful artisan bakeries, right? These factories have not stolen the jobs of these bakeries. We still like to go to the nicer ones usually, even though they're more expensive, even though they might be far away and hard to obtain, etc. So going back to my first question of whether or not AI can take our jobs as an astronomer, I think the answer was like maybe it might like get rid of all like the weak ones, the people who aren't doing great science anyway, but the ones that are doing novel things, like there's no replacing that. Thanks.